Okay, so I want to start today with a little thought experiment. Let's put a word right on the operating table.
Right.
Let's take the word human. Simple enough.
Yep.
Now imagine we take a scalpel and slice it right down the middle. So you've got who and man. The question is, do those pieces mean anything on their own?
I mean, do they have any semantic weight?
Exactly. Does the word human have semantic compositionality? Aristotle, 2,500 years ago, he looked at this and said, basically, no.
Right.
He argued if you split a noun like that, the meaning it evaporates.
And it sounds like a tiny little philosophical point, but that single observation kicked off a 2,000-year war.
A war over what, exactly?
Over the very architecture of words. Are they built from smaller, meaningful bricks, or are they these irreducible whole things?
And that is exactly what we are unpacking today. We're doing a deep dive into the evolution of the word and paradigm morphological model by James P. Blevins.
It sounds a bit dense, I know.
It does, but look, this is actually a story about how we misunderstand our own brains. It turns out that for, most of the 20th century, we thought language was like a factory assembly line.
Right, the Lego model, as you called it.
But now, thanks to some ancient Greek insights and modern computer science, we're realizing it's more like a web of predictions.
It's disassembly versus pattern recognition.
And honestly, the fact that modern AI might be proving the ancient Greeks right, that is a plot twist I did not see coming.
It's a fascinating arc. We're going to trace the history of this word-based model, this web model. We'll start with the Greeks, move through the Romans, and then take a bit of a detour.
Into the 20th century where we got obsessed with chopping words up.
And then we land right back in the present day, but this time with information theory.
So let's jump in. We're back with Aristotle. He's writing the Interpretazione.
Yeah.
When he looks at a sentence, what is he seeing?
Well, you have to remember, Aristotle was a logician first, a linguist second. He defines the word as the smallest meaningful part of a sentence. But his big contribution here is distinguishing between onomata and rhamata.
Which we translate as nouns and verbs, but I feel like Aristotle was a bit more nuanced than my third grade grammar teacher.
He was. It wasn't about person, place, or thing. It was about time.
Time?
Yeah. He argued that onomatoso, nouns, they have no reference to time. Human, horse, it's a stable concept.
It doesn't happen at 3 p.m.
Exactly. But rhamata verbs, they mark time. They anchor the whole thought in a specific moment.
Okay, that makes sense. But then he brings in this idea of falling, kousis, which I've always found so poetic.
Yes, kousis. It literally means fall. He used it to describe how a basic word changes form to fit into a sentence.
Wow, so.
Think of the basic form of a word like run as standing upright. When you need to talk about the past, it falls into a new shape. Ran.
That's such a dynamic way to see it. It's not static. It's like tumbling into place.
And the Stoics who came after him, they really ran with this. They introduced the term kleisis, which means bend or slope.
Which is where we get declension.
That's exactly where we get it. They saw the nominative case as the upright stick, and all the other cases were the stick, bending or falling away.
But there was some tension here, right? It wasn't all agreement. There was this huge philosophical beef between analogy and anomaly.
Oh, absolutely. And this is the central conflict of the whole thing. Aristotle was team analogy.
Meaning he thought language was systematic.
A system, a grid. If you know how one word behaves, you can predict how a similar word behaves. Logic is in charge.
And the Stoics were team anomaly.
They were. They looked at the sheer messiness of it all. They said, look at all these irregularities. Language is organic. It's chaotic.
But I mean, anyone who's tried to learn English and run into rough bowing, though, is probably on Team Stoic.
It's a very fair point. But here's why it matters so much for our story. The word and paradigm model, the one Blevins is talking about, it relies completely on Aristotle's view.
On
analogy. The whole theory is that we don't memorize dictionary rules, we memorize patterns. If I know the pattern, I can predict the new word. I don't need to take it apart.
So if the Greeks laid the foundation, the Romans built the house. Let's talk about Varro, 1st century BC.
Varro was brilliant because he made this crucial distinction between two types of word changes, inflection and derivation.
Okay, walk us through that,
Yeah.
because changing run to runner and run to ran feels like the same kind of process.
Varro realized they're fundamentally different. Inflection is, it's natural, it's predictable, it's a closed loop.
How so?
If I give you a Latin noun and say it's a first declension noun, you can instantly generate every single form of it. The plural, the genitive, All of it. It's automatic.
Okay, so that's analogy working perfectly.
Exactly. But derivation turning run into runner or act into action, that is wildly unpredictable.
What do you mean?
Well, you can't just apply a rule and assume the word even exists. We have arrival from arrive, but we don't have derival from derive.
Oh, we say derivation. That's true. And really annoying.
Varro saw that grammar is about this implicational structure. If X, then Y. Inflection follows that logic perfectly. Derivation, not so much.
And this idea stuck around.
For a millennium. Priscian, who wrote the definitive Latin textbook around 500 AD, he baked this right into the system.
And this is where we get principal parts, right? I definitely remember this from Latin class.
You got it. Memorize 3 or 4 key forms of a verb,
Yeah.
the principal parts, and you can predict the entire paradigm. But here's the critical thing the source points out.
What's that?
For over 1,000 years, Western linguists never felt the need to chop words into smaller bits. They explicitly rejected it.
Hold on, really? So nobody was looking for morphemes? No one was saying, hey, this little ed on walked is its own separate thing?
Not in the way we think of it now. They saw the endings, sure, but the unit of language, the atom, with the word, you just didn't split the atom.
So what on earth changed? Because I absolutely learned that unbelievable is unbelievable. When did we decide to become mechanics and start taking the engine apart?
Well, the bridge is really the 19th century, the New Grammarians.
Sounds like a cool band.
They were the rock stars of historical linguistics back then, guys like Schleicher and Paul. They were analyzing sound laws, looking at roots and stems to trace language families.
So they were peeking under the hood.
They were peaking, but, and this is a huge but, they still respected the word. Herman Paul said explicitly that breaking words into roots and suffixes is something grammarians do, not something speakers do in their heads.
So they weren't tearing the engine out yet.
Not yet. But then comes 1933, Leonard Bloomfield, the American structuralist movement. This is when everything just flips.
Okay.
Bloomfield looked at the success of, chemistry and physics, sciences that found success by finding the smallest indivisible particle. And he got jealous.
He wanted the atom of language.
He wanted the atom. He established what we call the morphemic model. He basically argued that words are an illusion. The real thing is the morpheme, the smallest unit of meaning.
So cats isn't a word.
In his model, no. It's 2 morphemes. Cat, the animal, and S, the plural marker.
It feels very industrial,
Yeah.
Like you take a root, weld on a suffix, bolt on a prefix, and ship it out.
And it was incredibly seductive. It felt scientific. It promised that if we just found all the little Lego bricks, we could explain every language on Earth.
And this was the dominant view for a while.
For about 20 years, it was gospel.
But the source points out something I found really surprising. This whole Lego empire, it crumbled really, really fast.
It did. By the 1950s, the cracks were everywhere.
Why? I mean, cat plus S equals cat seems pretty solid.
It works great for English nouns. It works terribly for almost everything else. The problem is in a lot of languages, you just can't find the brick. You have the meaning, but there's no distinct piece of sound that carries it.
Which brings us to P.H. Matthews in the 70s. He basically walked up to this Lego castle and just kicked it over.
He did, using 2 main arguments. The first one is called extended exponents.
Okay, break that down.
Sure. Let's take the Greek word alekete.
Alekete, got it.
It means you had unfastened. It's the pluperfect tense. Now, if you're a Bloomfieldian morpheme hunter, you need to find the specific sound that means pluperfect.
Right. Show me the Lego brick.
You can't. The pluperfect meaning is it's just smeared across the entire structure of the word.
Ow.
It's in the reduplication at the start, the
Yeah.
legence, and the suffix in the middle, and it's in the vowel changes. It's everywhere and nowhere at once.
It's like the salt in a stew. You can't reach in and pull out the salt once it's dissolved. It's just part of the flavor.
That is the perfect analogy. The meaning is distributed. It's not modular. If you cut the word up, you destroy the meaning.
Okay, so that's one hit. What was the second argument? Persianic syncretism.
Yeah, that's a mouthful. But syncretism just means when different grammatical forms happen to look exactly the same.
Like in English, hit is present tense and hit is past tense.
Exactly. They're syncretic. Now, look at Latin. The verb florere, to flower, lets you predict another form, the imperfect subjunctive, florerem.
Okay, florere predicts florerem.
Now, take an irregular verb, esse, to be. It still follows the pattern. Esse predicts essem.
Okay.
Here's the kicker. The stems, florere and esse, have nothing in common. There's no imperfect subjunctive Lego brick hidden inside the word essem.
So how do we know to go from essay to SM?
because of the predictive rule of the paradigm itself. The form is the key. It's not about adding a meaning brick. It's about navigating a map. The word model says, I recognize this shape, so I know what the next shape will be.
And the morpheme model is just left standing there asking, but where's the meaning unit?
Exactly. You can't explain it.
This feels like a huge shift in perspective. We're moving from language as a pile of parts to language as a web of relationships.
Precisely. And this is where the history lesson stops and the sci-fi starts.
Yeah.
Because it turns out that treating language as a web of probabilistic relationships, that's exactly how modern information theory works.
So this is where we dust off Priscian and introduce him to Claude Shannon.
Right. Claude Shannon, the father of the digital age,
Hmm.
he introduced the concept of entropy.
We hear entropy and we think of like the heat death of the universe, but it means something else here.
Think of it as uncertainty. Imagine you're playing Wheel of Fortune and the puzzle is totally blank.
Right.
Your uncertainty, your entropy is at its maximum.
Right. No clue what's there.
But let's say the letter Q appears.
Yeah.
All of a sudden, your uncertainty about the very next letter drops to almost zero.
Because it's going to be a U.
You know, with like 99% certainty it's a U. That is low entropy, high predictability. I mean, just apply that to grammar. A paradigm is just a grid of variables.
So when I hear a Latin stem like floor, my brain is drastically narrowing down the possibilities for what comes next.
Yes. And this validates Priscian's old idea of principal parts, but mathematically. A principal part isn't just some random form you have to memorize. It's a low entropy form. It's the form that gives you the absolute maximum amount of information about the rest of the word's family. It's the Q that predicts the U.
Wow. That is mind-blowing. So the Romans, with no computers, they basically intuited the data compression keys of their own language.
They found the nodes in the network that carry the most predictive power.
Yeah. And this connects to modern AI, right? To large language models.
It's the same exact principle. How do these LLMs work?
They predict the next word?
They predict the next word. They don't know grammar rules. They don't have a list of morphemes in a rule book. They are purely prediction engines.
Right.
They look at the paradigm of all the text they've ever seen and just calculate the statistical probability of what comes next.
So ChatGPT is more like a Roman grammarian than a 20th century linguist?
In a way, yeah. It's operating entirely on pattern recognition and analogy. It is the ultimate validation of this web model. The meaning isn't in the pieces, it's in the connections.
The source also makes this interesting distinction between the speaker and the hearer.
It frames them as two sides of the same coin. The speaker starts with the meaning, I need to talk about the past, and has to find the right cell in the grid.
And the hearer gets the form ran and has to work backward to figure out which cell it came from.
It's a coordinate system. It's an item and pattern system. The word is the item. The paradigm is the pattern. We are finally moving away from that factory assembly line and back to the web.
It's humbling, isn't it? We spent 100 years convinced we could reduce language to this hard science of atoms and particles, only to realize that language is looser and weirder and way more interconnected.
It shows that we often confuse our analysis with reality. We think that if we can break something down, then that must be how it actually works.
But if you break a word down, sometimes you just kill it.
The reality of language is in the network, not the nodes.
So, to bring this all back to Earth, what does this mean for us? For, say, the classroom?
I think it raises a massive question about education. I mean, think about how you learned a second language.
Oh, flashcards, memorizing verb charts. Drop the R, add the O.
Exactly. You were taught the Lego method. You were taught to be a mechanic. But if our brains and our best computers actually work by prediction and analogy, are we teaching it all wrong?
You're saying maybe we shouldn't be teaching the rules for disassembly.
Maybe we should just be exposing students to the principal parts, the high-value patterns, and then just trust their brains to build the network on their own.
The way the Romans did.
Exactly. Yeah. We try to teach students to build the car from scratch when we should just be teaching them how to drive the network. The Roman method wasn't primitive. It was, it turns out, psychologically realistic.
That is a really powerful thought to end on. Maybe the best way to move forward is to look back. Aristotle might have been right about the word human all along.
I think he'd be pretty happy to hear that.
That's all the time we have for this deep dive. Thanks for listening, and we'll catch you on the next one.